In this ShowMe, I'm going to demonstrate one method of solving problems involving percents. There are a number of great ways to do this, including just directly translating word problems about percent into equations. I guess that's kind of what we're going to do here, but we're going to translate them into a special kind of equation. We're going to translate them into proportions. We're going to restructure the content of questions into two ratios that have to be equal. In each case, one of the key numbers will be missing. We're going to discover that number. That's how we answer the problem. The formula in front of you, is over of equals percent over 100. It is a formula I use simply to organize the reading comprehension process for percent word problems, particularly the short ones, often presented on assessments as just one sentence. A lot of times when these questions are encountered in larger scale real world problems, the process of distilling paragraphs ends up creating just this one question, which then is easily translated. Again, this isn't the only way to do it, but this is a way to relate percents and proportions that can be very useful. For the first of three examples, let's look at what happens when the number that we associate with the word is missing. In this problem, the question is, what is 39% of 75? We're going to apply our formula. Every time you use a formula, I recommend that you write it down. That way it becomes committed to your memory. There is a place for memorization and learning, particularly when you are applying your particular knowledge to a general class of problems like this one. Is over of equals percent over 100. What number is associated with is? Well, as we knew from the beginning, the is number is missing. We'll use x to represent it. What's the of number? Well, the of number is the object of the preposition of. That's 75. And the percent number is pretty easy to find. It's right there with the percent sign. So the other ratio is 39 to 100. Now, use any technique you prefer for solving proportions. In our class, the favorite method of all my students has got to be cross multiplication. That's fine. X times 100 has to be equal to 75 times 39. 75 times 39 is 2,925. To discover x, then, we divide both sides by 100. X is 29.25. So 29.25 is 39% of 75. For our second example, we're going to solve this question. 84 is 63% of what number? Again, every time you use a formula, you ought to write it. Is over of equals percent over 100. Well, this time our is number is known. It's 84. Our of number, however, is missing. Of what number? So we'll put x there. Our percent number, again, is easily identified. 63 over 100 is the other ratio. Using the cross multiplication technique favored by my students, we have 63 times x equals 8,400. To find x, we have to divide both sides by 63. The answer then is x equals 133 and 1/3. Our third and final example is one where the percent number is the missing quantity. Again, we're going to use our formula, so we should write it. Is over of equals percent over 100. The is number, this time, is 72. The of number is 126. And our percent number is unknown. So we'll have x over 100 on the other side. Using cross multiplication, we have 126 times x equals 7,200. Dividing both sides by 126, we find that x is 57 1/7. Now this is a classic example of a problem that students encounter in algebra all the time. It's a problem of form and convention, not a problem of knowledge. We have indeed found the value of x, but we were asked a particular question. The question was to identify what percent of 126 72 is. Well, our answer then is supposed to be a percent. So while x is a solution, it's not the answer. The answer is 57 1/7%. This also happens in problems where you end up with measurements of various units, or square units, or cubic units. Teachers that are following best practices in the classroom will demand that their students have the correct units attached to the correct values. The percent symbol, to my mind, is no different. So I require my students, in a problem like this one, to attach a percent sign to their result. I hope that clarifies some of those basic issues. As I said, this is not the only way to solve percent proportion problems, but I like it as a way to set up and comprehend what you're reading, and to make the process a little more systematic. This kind of problem is an end of the problem situation. It should be something that you're doing after gathering data or comprehending a larger reading, and should just be almost an afterthought. It should be automatic. Not quite as automatic as your multiplication facts, perhaps, but it should come to you quickly, and the formula should help you remember that. If you want to discuss this or pass on some problems related to this that are giving you trouble, visit my blog at MikePoliquin.com. Post a question for me.